This video is a continuation of the last video tutorial on how to create a pedestrian simulation using the PedSim plugin for Rhino Grasshopper. In this tutorial, I'll be showing you how to visualize the PedSim results as a heat map. First of all, we will need to create a point in Grasshopper, which we can then reference a point created in Rhino to be the corner of our base map. So you type in point, select where we want the point to be, and then right click, set one point, and then set the point, click on the point. Next, we'll have to create another point, and then also a square grid, which will be where our heat map is based on. So we connect the first 2 points into plane. Just move that down a bit. And then we create a number slider. This is so we can edit the size of our grids. Just going to change it to integer and set a maximum number. We'll make it 100. We'll create 2 of these and plug them into extent Y and extent X. Create a third one so we can manipulate the size of the cells. Just change the numbers so that we can fill up our square with the squares from the square grid. And we just edit it accordingly. Let's make it a bit smaller. Yep, 55 should be good. Alright, now we need to create a grid speed counter. So just type in grid. This is our grid speed counter. And we will plug our points into the base point. And then we can also plug our number sliders for the extents into X and Y, just like we did for our square grid. Same with the number slider for the cell size. So now the grid speed counter and our square grid are connected.
So now we've got to set a gate OR component. We plug the result into reset. And then we will plug our gate OR into a button. This will let us reset our grid whenever we want to replay our heat map. Then we'll plug in our Boolean toggle button into our A input of our gate OR result.
Now we need to connect our PedSim to our grid speed counter. To do this, we'll create a data container. And we connect the people output from PedSim. And we connect that into the people input of our grid speed counter. Next, we'll have to create a division component. This will allow us to set our average speed for the grid speed counter. So do that, create a number. We'll plug that into B, and then now we'll create a number slider where we can set our max speed. We'll set the maximum value to 10. And we will plug that in. We'll set the speed to 5. Then we'll plug it in. And we plug in A to average speed. Next, we'll create a gradient. This will allow us to set the colors of our heat map. So we plug result into parameters. And now we create a custom preview, which will allow us to view our heat map in Rhino. Plug the output into materials. And now we create a mesh plane. plug mesh into geometry, and then we right click cells and select the flatten option, and then we plug that into boundary. Now we just set a number slider for width count and width height. We'll set that both at 1. Now we want to just change the color of our gradient so that it's not pink. We'll set this rainbow sort of colored one. And then we right click on the parameter option and we change that to expression, which we'll type in as 1 minus x. So now we just save the grasshopper document and also save the rhino document. So now our visualization aspect of our algorithm is complete. We can now play our simulation like we did before, which is to press toggle and turn it to false. As you can see now, our heat map is updating with the particles now showing us these colored results. I'll just speed up this process. Once the simulation has been playing for a bit, we have the option in Grasshopper to then bake our result. To do this, right-click on the custom preview and press bake. Select your layout and hit OK. Then we can select all meshes in Rhino, and then we just drag it aside. And then we can set the view to a rendered view. And then there we can see our baked colored heat map of our simulation. That is all for this tutorial. I hope you enjoyed it and I hope you learned something.